Hi, in this video, I'm going to be talking about capacity, and not just capacity, but the capacity and how it links to volume, because these two are related and yet counted separately, especially mathematically. So volume, we know, is the 3D space taken up or included by some sort of three-dimensional object. So let's just say I had this container here. Its space that it takes up, well, if it was a solid block, the space it would take up would be its volume, or if it was, say, some sort of a container, its volume could be the amount of space on the inside of it. Capacity is very similar. It is the fluid volume or gas volume, but we usually talk about fluid volume of a object. So if I had the same object, it's how much fluid I can fill in to that container or that box or that bottle or whatever. So with volume, we measured this in our units, our distance units cubed. So this could be, so many millimeters cubed, or it could be so many centimeters cubed, or so many meters cubed. Capacity is measured in liters. So it's how many liters of fluid I can put into this container. Whereas the volume is how much actual 3D space is contained within the container as far as little millimeter cubes. So you can sort of pretend volume is how many little tiny cubes that are, say, 1 millimeter by 1 millimeter, or slightly bigger cubes that are 1 centimeter by 1 centimeter, or much bigger cubes that are 1 meter by 1 meter by 1 meter. I forgot there's a vertical measurement there as well, even though this is a bit of a demented cube. So you can think about how many of these little cubes can I fit inside that box is what volume is. Capacity is how much liquid. So think about, how many dewdrops I can fit into that box. Not that I'm any good at drawing dewdrops. That was a worse attempt than the first one, so I'll give up. So we need to think about how these are linked. So volume and capacity are linked through one simple system, okay? If I have 1 centimeter cubed of volume, that is what we call equivalent to, and we use 3 equal signs to indicate the equivalent to, but a lot of people forget one of those and just write equals to. So it doesn't matter too much, but it's equivalent to 1 milliliter. So that's the base conversion. If I have a volume in centimeters cubed, I can just write its capacity as the same number in milliliters. For example, if I work out the volume of this box and I get, say that it was 523 centimeters cubed, that would be equivalent to it being able to hold 523 milliliters of liquid. Now this conversion, this direct conversion, only works centimeters cubed to milliliters. They are the only two that are exactly the same. Now, a lot of us, though, as I was talking about liters up here, and now I started talking about milliliters. So before we get into this too much further, let's talk about where does the milliliters sit within my liters. So liters, which is just given the letter L, liters, is the base unit of capacity. And milliliters is a thousandth of this, milliliters. It's a thousandth of a liter. It's a small drop of fluid in a much bigger container. So to convert from liters down to milliliters, so let's say I had a 5-liter container, I would multiply by how many liters I have by 1,000. So 5 liters times by 1,000 would mean it's a 5,000 milliliter container. Or if I had it the other way, like I've got 523 milliliters up here, what if I wanted to know what that is in liters? So to convert the other way, I would divide by 1,000 because I'm going from a small measurement, milliliter is a tiny little drop of liquid, up to a big measurement, what fits in a big barrel. So I've got to divide by 1,000 to see basically how many lots of 1,000 of these little things fit in the big thing. Now above that, we also have the kiloliter. Now the kiloliter doesn't get bandied around a lot, it doesn't get used a lot, but it does exist. And the kiloliter is 1,000 liters, hence the kilo. So milli stands for 1,000th of, and kilo stands for 1,000 of them. So we have the same thing. To go from liters, say I had that, let's say I have a 10,000 liter container, I would divide by 1,000, and that would say that I've got 10 kiloliters. And going the other way, I would multiply by 1,000. So if I had a 5 kiloliter container, I could multiply by 1,000, and I've got 5,000 liters. So that gives us this conversion between liters and milliliters. So if I go back up to my problem up here, if I wanted this 523 milliliters in liters, I could divide by 1,000, and that would give me 0.523 liters. And it would come down to the question whether we wanted that. So this 523 centimeter cubed container contains just a fraction over half a liter. Now to do this in something useful, we would want to actually have a look at the entire process. So let's say I have this cylinder here. So this cylinder is going to be a water tank. And it's a water tank, and it's going to have a radius of, say, 2 meters and a height, and this is very disproportionate because it's going to be 2.5 meters, so it's not to scale, but I have a cylindrical tank of radius 2 meters and height 2 meters. And I wanted to know how many liters does this container hold? Well, I would first work out the volume. So step one of doing this is you've got to work out the volume first. Now, to work out the volume of this shape, we start off with finding what's the area of the circle, and then we multiply by height, because this is a prism. And the volume of a prism is the area of the base multiplied by the height. So I can work out the area of that circle, which is pi times radius squared. And so I can have pi times by 2 squared. And so that gives me an area of 12.57 meters squared. And then to get the volume, I'm going to take that area and I'm going to multiply by height. And so that's going to give me a 12.57. Should make that clear, it's a decimal point there. Multiplied by the height of my cylinder, my tank, which is 2.5. And that's going to give me a grand total volume of 31.42 meters cubed. But I've got my volume in meters cubed, and I told you that the direct conversion was for centimeters cubed between capacity and volume. There is another useful conversion that we can use with this, and it is that if we have 1 meter cubed, then that actually tells us 1 kiloliter in fluid. So that's our second conversion between volume and capacity, and these are the only two we really have. 1 centimeter cubed is 1 milliliters. 1 meter cubed is 1 kiloliter. We don't actually have a direct conversion to liters. What we do is we get it into kiloliters or milliliters and then convert. So if I want to switch back to my problem, I know that my volume here, which I worked out to be 31.42 meters cubed, gives me a capacity of 31.42 kiloliters. So I've got 31.42 thousand liters, is that's how that reads. And if I want to get it in liters, well, that means I've got to convert. And we said before down here that to go from kiloliters to liters, I've got to multiply by 1,000. So to do that, I'm going to multiply this by 1,000 and get a capacity of, and if I do that using the exact numbers that I still have in my calculator, get a few extra decimal places, 31,415.93 liters. And so that's the capacity of this water tank that I've got in liters. And that's the process. Is step one, you find the volume, and then step two is you find the capacity from that volume, either turning meters cubed into kiloliters or centimeters cubed into milliliters. So if I just want to do another example, let's have a look, say, if I have a rectangular prism, let's say it's a box of some description. Maybe it could be a very simplistic swimming pool, I don't know, but we're going to have to do a box because I'm going to do this in smaller units. So let's say we measure up this box and it is 30 centimeters that direction. It is 20 centimeters in that direction, and it's 15 centimeters up. Okay, so now I want to find out the capacity of this, and let's find it again in liters. How many liters does this box hold? Well, again, step one is find the volume. So step one of finding my volume is, again, find the area. So I'm going to take this front rectangle here as my base area, which is a 30 by 15 rectangle. Rectangle is length times width. So I'm going to have 30 times by 15. So when I work out my area, I'm going to get an area of 450 centimeters squared. And then to get my volume, I'm going to have my area times by height, which is going to be that 450 we just worked out times by this height I haven't used yet. That's going to be my height. So times by 20. And so I'm going to put that into a calculator. And so we get 9,000 centimeters cubed for our volume. But I wanted the capacity in liters. So step two is write it as capacity. And so my capacity is in centimeters cubed. So that means that my capacity, if I spell it right, is going to be 9,000 milliliters. Because remember, our conversion is that milliliters and centimeters cubed are the same number. So I've got 9,000 milliliters. And so then if I want the capacity in liters, because I've then got to convert this into liters, then remember to convert milliliters to liters, I divided by 1,000. So my capacity, I'm just going to shorten capacity to C this time, is going to be 9 liters. So maybe if this was an ice cream container, that would be 9 liters of ice cream. Now I'm just going to do one last problem quickly, because what if just out of the information we're given, let's just say I have, now let's not do a triangle, let's just stick with another rectangular prism just to make life quick and easy. What if we think about, what if I was given that this was 100 millimeters and this was, say, 50 millimeters and this was 40 millimeters? I've got this in millimeters. So if I go and work out the volume of this, eventually my volume is going to be some number in millimeters cubed. But I don't have a conversion for millimeters. I can't convert millimeters to anything capacity. I can convert meters cubed to kiloliters and centimeters cubed to milliliters, but I cannot convert millimeters cubed to anything in capacity. So what I will have to do before I start is convert every single one of these into at least centimeters. So remember, to convert millimeters to centimeters, we divide by 10. So I'm going to get 10 centimeters divided by 10, 5 centimeters divided by 10, 4 centimeters. And then I can go and get the area. Let's say I use this rectangle this time as my area. So I've got a 50 by 40 rectangle. So my length times by width is going to be 5 centimeters. I've got to remember to use those centimeters, times by 4 centimeters, which is going to give us a 20 centimeter square rectangle. And then multiply by my height measurement, which is in centimeters, 10 centimeters, to get volume, being that area times by height. So I'm going to have that area we worked out of 20 centimeters squared times by the 10 centimeters squared, and I get my volume to be 200 centimeters squared. I now have I now have it in centimeters cubed, which I need. So now when I get my capacity, I can just write this as 200 milliliters. So I just convert from centimeters cubed to milliliters. And that would be fine because 200 milliliters is not a great number, but just for instance, we wanted to convert that to liters. I could again divide by 1,000, and that would give us 0.2 liters as our final answer if we wanted it in liters. So, if you are asked for the capacity of an object, you are wanting to know its value in either liters, milliliters, or kiloliters. And our conversion for that, our process is first find the volume in either meters cubed or centimeters cubed, use the direct conversion of centimeters cubed to milliliters or meters cubed to kiloliters, and then if you wanted liters, either divide by 1,000 or multiply by 1,000, depending on which way you're going to get it into liters. Remembering, of course, that if you got something in, say, millimeters, we can't get a conversion, so I have to first convert my millimeters to, say, centimeters to get my volume in centimeters cubed, so I can convert to capacity.